Greetings class again. We are back with the video lecture. So up till now we have completed till example number 4 and I hope you are studying well and revising whatever I have taught you and whatever video lectures I have shared with you. Right, so far I have not received any queries, so I believe that you all have understood up to this page number 6 all the examples and all. So today I'll move on to the exercise, that is exercise 1.1. Okay, so this is use Euclid's division algorithm to find the HCF of 135 and 225. Okay, so this is your first question. You have to use Euclid's division algorithm, right? So if you remember what we have studied there, what we do, we got two numbers, right? And we have to find the HCF of these two numbers. We wrote, let us use Euclid's algorithm to find the HCF. So by Euclid's division lemma, using Euclid's division lemma, I hope you understood that this is division lemma. How can you write this? You can very well write this in the form of A is equals to BQ plus R, right? And here 225 is greater than 135, right? So if 225 is greater than 35, then your form will be 225 equals to 135 multiplied by the quotient and then the remainder. Okay, so I'll just mark this rough, and what will you do? You will divide this 225 by 135. By 135 you will get what? You will get 0 here and 90, right? So this is 1 and your remainder will be 90. Okay, again your next step will be, you will be copying this here, right? So this will be 135 equals to 90 multiplied by the quotient, and then you will add the remainder. Then again 90 as the divisor, 135 as dividend, and this will again go by 1, right? So 190 and you will get 45. 145. One step more, you will be getting 90 equals to 45 multiplied by 2, and this will be 0. See, we know that 45 multiplied by 2 is 90, so I have written this directly here instead of doing your rough work. So as soon as we get the remainder 0, you get this HCF, and your HCF is 45. Therefore HCF of 135 and 225 is 45. Understood? So this one was your first part of first question. Okay, this is how you will be writing, and similarly you can do second one and third one, right? So I hope you have started making notes, and now you can also start doing your exercise in your test copy notebook. Now, okay, so this was for the first question. Now the second one is, show that any positive odd integer is of the form of 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. Okay, try and understand this question. See, this is very much similar to your previous examples that I have already discussed, right? So I'll just move on to this example. What we do, see, if this was your example, this is similar to this one, so I have to discuss this again. What we did, we took a as any positive integer, then we took b is equals to 2, the maximum value of this constant number, which is written with this divisor, with this question, sorry. Okay, so this is the same thing we'll be doing here. Okay, now let a be any positive integer. I'm not writing odd because that we will be proving later on. First, we are concerned with that a is any positive integer, right? Now this can be, now you can take also b is equals to 6. So we took b is equals to 6 because we can see that the highest value of this constant number is 6. So we took 6, and now from Euclid's division lemma, how can you write? You can write in the form of a is equals to bq plus r, right? So your a is equals to 6q plus r, right? Now what you know that your here you know the value of r. R is what? R can be either 0, 1, 2, 3, 4, 5, but not 6, because you know that 0, your value of r lies in between this, right? And your b is equals to 6. So r will be either 0, 1, 2, 3, 4, 5. This can be the value of r. Now we will start substituting this. Your first one is a is equals to 6q plus 0. So this will give you 6q, right? Second one is a is equals to 6q plus 1. This will remain the same. And third one is 6q plus 2. And now we can write this at 2 after taking 2 common. This can be 3q plus 1. And similarly you can move on. A is equals to 6q plus 3, right? Okay, now this can also be written as 2 times of 3q. So this, from this it is very much clear that when the values, when the value of this remainder is either 0, 2, 4, we get this even. How? Because these are divisible by 2. But can you divide this? No. Can you divide this? No. Also, okay, just take all the values. 6q plus 4, taking 2 common, 3q plus 2. This is also divisible by 2. The last one is equals to 6q plus 5. So this is odd, right? So I hope you have understood that for any positive odd integer, any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5, right? Therefore, you can write the end statement by yourself of the form 6q plus 1, 6q plus 3, and 6q plus 5, right? So this was your question number 2. I hope you have understood. If you face any problem, you can contact me anytime, right? Okay, now we should move on to the next question, that is your third one. Okay, I suggest you that you should always keep your maths textbook with you whenever you are watching this video lecture. So this is easier for you. Okay, now question number 3. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So see, this is very much clear that you must have seen that army parade and all. So you see that all these have equal number of rows and columns, right? So the values are fixed. That means their common factor will be used to get the maximum number of columns in which they can march, right? So nothing is to be done here. Now just calculate the HCF of 616 and 32 and you will get your answer, right? So you will be doing this by yourself. Question number 3, do it by yourself, right? Now your next question is question number 4. Question number 4, use Euclid's division lemma to show the square of any positive integer is of the form of 3m or 3m plus 1 for some integer m. Right. So this is similar to the previous question, that is question number 2, but there is a bit difference, small difference, right? So you can clearly see the hint, I guess. But even if you don't see the hint, you will get to know how to do this question. I will be explaining you right now, right? So see, Euclid's division lemma, let x be any positive integer, then it is of the form of 3q, 3q plus 1, 3q plus 2. Now square each of these, right? So obviously first you will be taking any number. They have provided you an x with a hint. So if you take any number, any positive integer, let x be any positive integer of the form 3q, 3q plus 1, 3q plus 2. Now see why we have written this 3q, 3q plus 1, 3q plus 2. So if you look at your previous question, you can very well get that one of the value will be odd, one of the value will be even, odd, even, odd. If you can keep on putting values, see if the value of q is 1, so you will get 3 here, and you will get 4, then 5, and then so on. So ultimately you are getting your consecutive numbers, right? So we have taken 3 because we can see that in your question the highest value of this coefficient is 3. So for our convenience we have taken this 3, x in the form of 3q, 3q plus 1 and 3q plus 2, right? So first of all we'll write for our first one x, sorry, x is equals to 3q. Now your x square will be 3q whole square, right? So 3q whole square will be 9q square, right? And we can write it as 3 times of 3q square, right? Now next one is x is equals to 3q plus 1. Now your x square will be 3q plus 1 whole square. Squaring this you will be getting 9q square plus twice of AB, right? Twice of AB is 6q plus 1. Now I can take 3 common from here as well. So 3q square plus 2q. I'll let you know why I'm taking only 3 common, not the q. Next, x is equals to 3q plus 2. Now x square will be 3q plus 2 whole square. This is 9q square plus twice of plus 4, right? So I can split this one as 9q square plus 12q plus 3 plus 1, right? Now again I can take 3 common, so this will be 3q square plus 4q plus 1, and the bracket closes, plus 1 plus 1, right? See, okay, please don't mind my handwriting. I am facing trouble in handling this pen, digital pen. So okay, now see why I took this 3 common everywhere. See, in your question it was written that this is of the form of 3m or 3m plus 1, right? So 3m plus 1, here it is written for some integer m. That means m can be any integer. You need not to worry that their values must be same or and all, right? It can be anything. It can be anything. But see, from here we can say that we can take this value as 3m. This is 3m plus 1, and this is also 3m plus 1, right? So we can very well write the square of any positive integer in the form of 3m, 3m plus 1, right? These are the only form in which we can write square of the positive integer, right? So this was your question number 4, and this question number 5 is similar to question number 4. So I'll suggest you to try this question as well. So your today's task will be, you will be doing question number 1. Wait. You will be doing question number 1, second, and third. Question number 3 and question number 5. These are your homework, and whatever I taught you, that is question number 1, part 1, question number 2, question number 4. These are your classwork. Basically, you all will be doing this in sequence, question number 1 to 5. Write in sequence in your maths notebook, and I want everyone to solve this. Click a picture and send me personally so that I could cross verify that you are copying this information in your notebooks, right? So this is for your exercise 1.1. Next I will be teaching you the fundamental theorem of arithmetic. For that I have already shared a video lecture that I found very interesting. So again I will be sharing the introductory part of this fundamental theorem of arithmetic, and the rest I will be explaining it myself so that you can very well understand that topic, right? So this is for today's class. Thank you so much.